Okay, in this video, we're going to start looking at three-dimensional figures, and we're going to start measuring them. To start things off, we have a polyhedron. This is basically the three-dimensional version of a polygon. So it's a three-dimensional solid, and it is made all of polygons. Those polygons we call the faces. So here are some examples of some polyhedron. You've got a pyramid there. The one to the upper right looks kind of like a cube or a rectangular prism. And then the rest of those polyhedrons have multiple different types of faces. So some of them have triangular faces. That one kind of in the center, the pinkish one, has pentagonal faces. The one in the bottom right has more triangular faces. So those are all polyhedron. We're going to focus on a couple types. We're going to look at prisms. So a prism is a polyhedron where two faces are parallel and congruent. We call those things bases. So those prisms, we name those according to their bases. So if their bases are triangles, we would call it a triangular prism. If the bases were octagons, we would call it an octagonal prism. So for example, here in the left, I have these two bases. They look like they're on top and bottom. Now be careful because the bases, it's all about the two faces that are parallel and congruent. It doesn't really have to do with the orientation, meaning it's not always going to be top and bottom. The way I have these drawn, though, they are the top and bottom. So I have this triangle, and then opposite to that, I have another triangle. So this is a polyhedron where those two triangles appear to be congruent and parallel. So this looks like it would be a triangular prism. In the middle, that one looks like it might be a square prism or maybe a rectangular prism because actually with rectangular prisms, you can kind of look at them in all different ways, and the bases could be any two opposite faces there. The one on the right here looks like it is a pentagonal prism because I have a pentagon up top, a pentagon on the bottom. They appear to be parallel and congruent. Now, the distance between those bases, that's what we refer to as the height of a prism. So those are all going to be like heights of rectangular faces. So prisms, they'll always have, we call those the lateral faces. Those are the faces that connect the bases. So the two faces that are congruent and parallel, we call bases. The faces that connect all of those, which are all rectangles, we call the lateral faces. And the height of any of those rectangles, we refer to as the height of a prism. So let's take a look at, first off, the two types of area that have to do with prisms. So first we have lateral area. This is the area of a solid where you only take the area of a lateral face and add all those together. That total would be what we call the lateral area of a solid. For the total surface area of any solid, this is going to refer to prisms today, but then we're going to extend this to pretty much any solid. That's going to be the area of any lateral parts plus the area of any bases, because remember, the lateral faces are not bases themselves. So let's take a look at a concrete example here. This prism here looks like it is a rectangular prism. So up top, I have a green rectangle, and then that side blue one is a blue rectangle, the pink rectangle's there. Now imagine this is a box, and you kind of like cut along the edges there, and you unfolded this box. So here I have a 4x3 rectangle, a 5x4. So the height of this prism looks like it's 4. That's the distance between the bases. And then this top one here looks like a 5x3. So if I was to unfold all of those and lay flat, I'd get a picture kind of like this. So again, if you go there, if you maybe fold this green one up, and then on the bottom, you can't really see because it's hidden from those front two faces, there's an exact copy of this green one. You'd fold down and then et cetera, et cetera. If you lay that flat, kind of like if you have a box and you unfold all of its flaps and then you lay it on the ground, it looks something kind of like this. So comparing this flat version of that prism to when it's all folded together, the green rectangle looks like it's the base. So here I have two bases, two green bases. And then the blue and the pink rectangles, those are going to be my lateral faces. So if I wanted to find lateral area, I would take the area of all those lateral rectangles and add them together. So to do that, I could do 4 times 5 plus 4 times 3 plus 4 times 5 plus another 4 times 3. Now, if you think about that, So let's look at this base here. These bases are exact copies of each other. This base is going to be 5 by 3. So this is 3 and this is 5. If you add that together, 5 and 3 and 5 and 3, that comes out to be 16. So the perimeter of this base is 16. Let's take a look at if I add those rectangles. So 4 times 5 is 20. I've got another 20, so there's 40. This makes it 12, and another 12. Looks like 64 altogether. So the lateral area is 64 square centimeters. Now, I could have gotten that by taking the perimeter of my base and multiplying by the height. You get the same thing. So that's one formula we're going to look at. Perimeter times the height of your prism gives you your lateral area. And if you want to find the total area, all you're going to do is take that lateral area and add any bases. So to do that, I would take all of these rectangles, including the two green ones, and then add their areas. So some formulas to know for any prism. Capital L for the lateral area is going to be pH, where P is the perimeter of your base and H is the height of your prism. T for total, or some people put SA for surface area, that's going to be pH, that's lateral, plus 2B. Now these are for prisms. The reason why I have 2B, capital B here is the area of your base. Now your base might change. Your base might be like this rectangle, which has an area formula of 1/2 base times height. Or it might be a regular polygon, which has an area formula of 1/2 perimeter times apothem. So this capital B has itself several different variations, could be any one of those area formulas that we looked at in chapter 11. So no, you can't forget those just yet. You still need to use those, which is kind of why some of those area calculators some of us worked on in Google Sheets are going to really help. That should get you started on 12.2.